Hello, my name is Sean Nog, and today I will be discussing Physics 2212 Lab 2, Lines of Charge. In this lab, we'll be going off of Lab 1, which is about charge tapes. And in that lab, we calculate the excess charge and deficiency of electrons on a piece of tape as it interacted with another charged piece of tape. Most importantly, in Lab 1, we modeled the interactions between the tapes and made the calculations with the assumption that the charges on the tapes were point charges. And here in Lab 2, we will be assuming that there is a line of charge, which will involve a more sophisticated model, which will be done in Glowscript. So again, just to reiterate, unlike Lab 1's assumptions, in Lab 2, we're treating each tape as lines of charge, which are evenly distributed along each piece of tape. This will allow us to create a different, potentially more accurate model of the interaction between the two charge tapes. Also, in this lab, we are still using the assumption that the top tape, and this picture shown as tape B, is the system, with tape A, the bottom tape, acting as the surroundings. Another assumption is that we are ignoring air resistance. And again, we're looking at these tapes as if they were lines of charges. Just as a bit of background, in Lab 1, I created two charged tapes through friction when I put the two pieces of tapes on another piece of tape that was stuck to the table and then ripped it off, which transferred charges to each piece of tape. I observed the interactions between each of the charged tapes and other objects, such as a negatively charged pen, neutral notebook, my hand, which is neutrally charged, and I found the tapes to be positively charged, and they both had the same sign. Next, as shown in the picture on the right-hand side, I took one of the tapes, put it underneath, and floated the top tape above the bottom tape. And over here, as I will get to next, were some important physical principles and forces. The actual physical principles involved in Lab 2 are similar to that of Lab 1. Here we studied net force, Newton's second law, and Coulomb's law. Newton's second law describes the gravitational force of the Earth on the top tape, and Coulomb's law helps us describe the electric field from individual pieces of charge of the bottom tape acting on individual pieces of charge on the top tape. Here is the most important part of Lab 2. I've shown two screenshots of my Glowscript code, one of the actual code and one of the image or the 3D model that the code produces. So in the image, we have our two lines of charge, which are the red and blue clusters of charge. The red cluster is covered by the green arrows, which I'll explain in a second. Force of gravity and electric force vectors are represented by the yellow and white arrows respectively. The array of green arrows, which I just mentioned, represent the electric field felt by each individual piece of charge on the top tape, dq, by the bottom tape's individual pieces of charge. As shown below the image, the magnitudes of the forces of gravity and electric force are approximately the same. The magnitude of the charge on one piece of tape, as calculated by my computational model, is approximately 1.9 times 10 to the negative third coulombs. So here are a couple of discussion questions. First one talks about comparison between the single point charge model and the model used in this lab, the line of charges model. So in the point charge model, I got a value of 9.33 times 10 to the negative 9 coulombs for the charge on one piece of tape. Whereas in this model, the line of charges, I got a value of 2 times 10 to the negative 8 coulombs. Follow-up question is, why do these estimates differ and which is more likely closer to the real value? I said that the difference is because of the calculation steps. In the line of charges method, we separated each piece of tape into small pieces of charge and calculated them by summing the electric force on each individual piece of charge. Whereas with the first method, we simply just use Coulomb's law for a single point charge. And I said that the line of charges model is probably going to be more accurate because that represents the real world situation in the experiment better than the point charge model. So in conclusion, the line charge model is going to be more accurate than the point charge model, and going off of that, we have different values for each model. That concludes my discussion on Lab 2, and thank you for watching.